So we are moving into a new unit, and that is good for you because think about this. We ended the last unit. Now we're starting a new unit, and guess what? We didn't have a test or anything. So don't worry about that, right? We'll probably have a quiz in a little bit when I get a little bit way through this unit. For the most part, no quiz, right? No test. Unless somebody annoys me. If you know someone annoys me, because I'll throw a quiz at you. But the new unit that we're moving into is on polynomials. Now, if you break down the word poly means many, and nomials just mean like terms of numbers. Number terms. Let's call it number terms. So we're saying that we have many number terms, right? You guys are used to monomials, which is just one number term. So like 4 would be a monomial, 3x would be a monomial, 3x squared, 4 a squared, b squared, c. All of these are monomials because they're one term, right? A binomial is two terms, right? So we would have something like 3x plus 2 would be a binomial, right? It's got two components. A trinomial would have 3. Everything after 3, we just say polynomial. But all of the monomials and binomials all fit into that same category under polynomial. They all fit under there. But because you notice when we move into binomials and trinomials, we've got powers, right? Like if I had I could have a polynomial that's like x to the 5th plus 3x to the 4th minus 2x cubed plus x squared minus 7x plus 3, right? Because of that, because with polynomials, we're working in things of larger degrees, I thought I would start this unit by reviewing the rules of exponents. All right. And so that's how we're going to spend our day today. We're going to go over the rules of exponents and we're going to play with some examples. So we're going to do it in a different color because I'm not a fan of the green. That's not my favorite. But I do love the blue. So we're going to talk about rules of, I don't know why I'm writing P for the word exponent, but I was. Rules of exponents. So we're going to start with the product rule, which product in and of itself implies multiplication, and that is what we're talking about right now. The product rule says that if I have something of base A raised to the power of m, and I multiply it times something else of base A raised to the power of n, then we get A to the power of m plus n, right? It just means when we're multiplying things with exponents, we add the exponents. So, for example, if I have x to the 3rd times x squared, I wind up with x to the 3 plus 2, or as we would write that, x to the 5th power. Make some sense? You guys have seen this before. This is really kind of a review, right? Sometimes you don't even think about the rules of them. You've just been doing them for so long. The power rule is when we raise an exponent to an exponent. So if I have a to the power of m and I raise it to the power of n, then we multiply them. then I get a to the m times n, or a to the m n. And if we see that in terms of a number, if I have x cubed and then I square it, I wind up multiplying those numbers, right? That becomes x to the 3 times 2, or x to the 6th power. So we've done product and we've done power. Now we're going to do what we call quotient. Quotient deals with division, right? Now, we say that if we have a to the m over a to the n, the rule would be that that can equal a to the m minus n, right? So if I have x cubed over, if I have x cubed over x squared, it equals x to the 3rd minus 2, which is just x. I always like to think of it in terms, when I'm dealing with division, when I'm dealing with quotients, as a cancellation. Like if I have x to the 4th over x, I always think of it in terms of having a line, right? I have 4 x's here. Because of this, I can cancel one on the top and one on the bottom, right? And I would wind up with x to the 3rd. That's how I always like to think of it. I like to think of it as a cancellation. The one where I have less cancels the one where I have more. So if I were to have, say, m to the 4th n squared over m to the 3rd n, right? I go, well, I have 4 m's here and 3 here, so I can cancel 4 of these, and I'm left with 1. Here I have 2, and I can cancel 1, so I'm left with 1. And that's how I kind of think of it. But you can think of it as, well, I've got 4 minus 3. I have 2 minus 1. Does that make some sense? Can you follow that a little bit? Okay. The next rule we have is the negative exponent rule. Now, the negative exponent rule says that if I have a to the minus m, I can rewrite that as 1 over a to the positive m. Now, keep in mind, that works in either directions. Also, if I have 1 over a to the minus m, I can rewrite that as a to the positive m. So when I'm dealing with negative exponents, if I have multiple exponents, well, let's just do a regular one first. So if I have x to the negative 3, I can rewrite that as 1 over x to the 3rd, right? Or if I have 1 over x to the negative 5, I can rewrite that as x to the 5th. That's all right, America. It's all being recorded. Make sure you get complete notes, though, because that is your homework today, is to turn in the notes. So make sure before you turn it in, you catch the beginning of this video. Last rule we've got is the zero exponent rule. This is the one where teachers try and mess with you, and I am one of those teachers. I get pure joy out of it. The zero exponent rule says that a to the 0 power equals 1. Anything we raise to the power of 0 equals 1. So if I have x to the 0 power, I have 1. But also if I have 3x to the 4th plus 4x squared minus 2x plus 3, and I raise that whole thing to the 0 power, the whole thing equals 1. So, I said that's where teachers like to mess with you. I love to give problems like this where there's all this crap you got to do on the inside, and then you look at the outside and you're like, shoot, the whole thing's raised to the power of 0. It just equals 1. So those are the rules. Now we're just going to see how we play with them. All right. So if I have, for example, 5x squared times negative 7x to the 6th, following those rules, this is my a to the power of m. We're just multiplying these. So all we're going to do is add the exponents. They are like exponents, right? So we can start by multiplying the numbers. We have 5 times negative 7. Well, that's negative 35. And here I have x squared times x to the 6th. Well, x squared times x to the 6th is just x to the 2 plus 6, which is x to the 8th power, right? Another example would be if I have negative 2a cubed b, and I square that whole thing, and then I multiply it times 8ab to the 9th. Now, one thing I want you to pay attention to is this cube only goes to the a, right? Here, when I square it, I'm going to square each piece. This square goes to each piece. It goes to the negative 2, it goes to that a cubed, and it goes to that b. But here, when I have this b to the 9th, this 9th power, it only applies to the b because it's not on the outside of parentheses. It's only applying to what it's raised over, right? In the same respect that this a to the 3rd is only applied to the a, it doesn't apply to that negative 2, right? So we're going to go, okay, negative 2 times negative 2, negative 2 squared is 4. A to the 3rd raised to the power of 2, we multiply those powers and we get a to the 6th. Here we have b raised to the power of 2, which is just b squared. And we're going to multiply that times 8ab to the 9th power. And now we can just multiply our like terms. We've got just our numbers. We've got 4 times 8, which is 32. We have a to the 6th times a. So a to the 6th times a to the 1st gives me a to the 7th. B squared times b to the 9th is b to the 11th power. Does that make some sense? Are you kind of getting a feel for that? Let's do an uglier one. Let's do, if I have 54 m to the 6th n to the 4th. Sorry, I can't see with my glasses up close, but I need them to see how far. 3m squared over n, 3m squared n minus 10m to the 4th n to the 3rd. So I like this problem because it's asking a lot of you, but when you look at it and break it down in pieces at a time, you're like, oh, it's not that bad, right? So to start, we're just going to start fixing the problem. We've got 54 divided by 3. What is 54 divided by 3? I know it goes evenly in because 4 plus 5 is 9, which is divisible by 3. So this will go in 1, 18, right? Here I have m to the 6th over m squared. That's like saying 6 minus 2, right? M to the 6th minus 2 is going to give me m to the 4th. n to the 4 minus 1, right? I've got 4 here. I've got 1 here. So n to the 4 minus 1 is just n to the third. So we no longer have a denominator there, right? It all came to the top. So now we're left with 10m to the fourth, n to the third. And if you look at that, you can see that now they are like terms, right? We have 18 m to the fourth, n to the third, minus 10 m to the fourth, n to the third. So since our variables are all the same and of the same power, we can just go ahead and subtract the numbers, right? And we're left with 8m to the fourth, n to the third. The last thing I really want to work with you on before I let you go is when we were dealing with negative exponents. Think about this. This is going to be a crazy example, but I'm going to have like, say I have 15x to the negative 4, y squared, z to the negative 1. Okay, we'll start with that, right? If I want to rewrite this problem with no negative exponents, I'm just going to draw a line, right? Here, 15 doesn't have anything, right? So I could just write it back here on top of this line as 15. Well, here I have x to the negative 4th. If I want that to be positive, I can just write it underneath as x to the 4th. Here I have y to the squared, y squared, so we will keep it up like that. Here my z is to the negative 1, and so to make it positive, I can write it under. Does that make a little bit of sense? Can you kind of get a feel for how the negatives work? I'm going to give you one more example of it. And I'll start by using the same starter where I had the 15x to the negative 4, y squared, z to the negative 1. And I can write that over, looking at the board because I did this one earlier, 5x to the 5th, y x to the 5th, y to the negative 3 down here, z to the negative 3. When I see a problem like this and it looks crazy, right? All I do is I draw the line. And I'll draw it big at first because I might have to combine things later. First thing I've got is my number. 15 divided by 5, well, that's just 3. But now I have x to the negative 4. Well, my x to the negative 4 is going to have to come down below, right? Y squared, that's going to stay right where it is. Z to the negative 1, that's going to have to come down below. And so now I've got to keep what's left, right? We already got rid of that. We made it a 3, but I still have that. Sorry. When it comes down below, it becomes positive, right? So when I bring that x to the negative 4 down, it becomes positive 4. When I bring that z to the negative 1 down, it just becomes z. But now we still have all of this. We have x to the 5th. Well, here we have y to the negative 3. If I bring it up here, it's y to the 3rd. Right? Here I have z to the negative 3. If I bring it up here, it's just z to the 3rd. Right? So everything's in its place now, and all we have to do is reduce. So let's put them in order. I have 3. Well, y to the 3rd times y to the squared is y to the 5th. Z to the 3rd. And then we've got x to the 4th times x to the 5th. Well, that's x to the 9th, z. And now we just reduce where we can, right? Here I have 3 z's. Here I have 1 to cancel, right? And so I get 3y to the 5th z squared over x to the 9th. So you want to treat it in pieces. Does that make some sense? Are you guys feeling that at all? The good news is you're not going to have any homework in this tonight. The bad news is you're going to have homework in it on Thursday. right? So make sure that you take proper notes, because remember, your homework for this class today is to churn in the notes. Take a picture of the notes that you took and